last time of the day. It's been hot. It's been a long couple of days, and you all could be eating dinner right now. So I really, we both appreciate that. We're not going to make it a waste of your time. What we're going to talk about today is an independent evaluation of a VPN system. We're going to talk about it in terms of methodology, starting with what makes a VPN work, things like that. In the end, we're going to show you vulnerabilities we found in a real system. Unfortunately, due to NDAs, we can't tell you the details of that yet. There's people out there that are vulnerable, and we could have a whole philosophical discussion about whether it's getting quashed by the vendor or whatnot, but that's all really complicated, and we just really don't want to get our lives taken away from us in a lawsuit. So first we're going to talk about the point of this whole idea. Why test systems in the first place? We're going to talk about when you're an organization looking to implement a VPN, what are you facing? What do you got to think about? What do you have to worry about? We're going to talk about when you're writing a VPN, if you want to architect one of these things, what do you have to keep in mind? What are the minimum things that a VPN must do in order to actually be functional as one? And finally, we're going to look at the theoretical VPN, which is in rough shape. Okay. Why go after VPNs? I mean, why not hack something else, And I'm just going to pretend that we're all good guys here for a minute and just tell you straightforward what it is that I see happening as kind of a historical perspective and what's happening right now. Once upon a time, firewalls were new. And they were the thing that businesses would do to secure themselves. You'd hear it, and it was like, oh, we've got a firewall. We're fine. We don't have to worry about anything. We're safe now. And it didn't, it's not like we've got this kind of firewall, and like nowadays you'll hear people say, oh yeah, we're running Checkpoint 4.1, we're current on the patches, we got a Nokia 650, we're using VRRP to balance them, we got failover, they're detailed about it, and the reason why is because now they know that there's a difference between one firewall and another. It used to be, it wasn't that way, it was like, we got a firewall, that's fine, because they didn't know the difference. They didn't know the difference, that is, until people started taking firewalls and poking around them and trying to find ways to break them, find ways to get around them, ways to make them fail, find what's wrong with them. Once they did, they told the public. Once they told the public knew, and at one point, everything changed and people started paying attention when they bought firewalls. Well, now it seems to be that way with VPNs for the most part. People look at the box, they listen to the sales pitch, they hear triple S, okay, it's fine. It's not. VPNs can be good, VPNs can be bad. People don't know how to tell the difference yet, and so it's like the emperor's new tailor. Okay, maybe it's a good VPN. Maybe it's, sorry. Thank you. I'm running off my notes here on paper, and I've got this up here. VPNs are the new emperor's haberdasher, so to speak. Maybe the emperor really is nicely clothed. He's all set, he's covered, everything's beautiful, he's styling. Then again, maybe he's just butt-ass naked, and nobody knows yet. Somebody needs to go down to the parade and see if they can get a look at his crown jewels. And that somebody is us. Who else is going to do it? I mean, the people who make the VPN, there's no motive to do that. And this is a well-known, the capitalist system, I've heard, is the worst one in the world except for all the other ones. And it's true. There's drawbacks. We know that. And one of those drawbacks is that businesses tend not to police themselves. There are good ones. They do the right thing. They're altruistic. But for the most part, we know. We're not stupid. Don't count on industries to police themselves. Have to have somebody looking over their shoulder, making sure they're doing the right thing. That's why we have some degree of regulation. That's why we have watchdog groups. That's why we have DEF CON. Thank you. The client, typically, all the clients out there, you can't expect all of them to know how to assess a VPN in a really deep way. They just don't have that expertise. That's why security consultants are still doing pretty well, even with the tech slowdown. There's demand out there for the expertise. It's kind of scarce. So definitely the clients don't have it. So the best bet is somebody who doesn't have any kind of a vested interest. And again, that's us. We're not getting paid by one. We're not getting employed by the other. we take a VPN, we look at it. If we find a hole, we get bragging rights. But we can't make it look like there's a hole if there isn't. And it's as simple as that. Okay, basics of VPNs. They can encrypt all traffic or just specific kinds of traffic. That has to do with the Rulebase. Go into that later. They can encrypt between two computers, 2 points, or between entire networks, enabling you to kind of extend your LAN to a certain degree out to a remote location. They can be hardware-based, like the Red Creek products or Cisco. Or they can be software-based, like Checkpoint or any number of other options. And they'll use various levels and types of encryption based upon whether or not they're intended to be exportable. And that's a very critical point that we'll stumble upon later. Oh, one thing, just want to throw this out there. I'm really disappointed that XOR didn't get chosen for the new AES standard. You know, double XOR. Oh, hey, triple XOR. What do you think?
XOR's mad fast.
Yeah, XOR is mad fast. Mad fast. Okay. As you all know, export restrictions are based upon key size. Now, one thing a lot of you don't know is although the restrictions have been lightened up, they haven't been lightened in exactly the right way. You can export triple S provided you do key escrow. That's a little bit of a problem. Key escrow is a slight nightmare, and we'll talk about that why. Okay, so you are company Y. Okay, what do you get from using a VPN? One, if you've got multiple offices, you can share network level resources securely between them without a lot of trouble. You don't have to have dedicated lines. You don't have to have really expensive dedicated lines. You don't have to mess around with it, and you don't have to worry about security. You can have your Exchange server back at the home office, have your desktop user in another state, pull up Outlook, authenticate to the Exchange server, pull up their mail. It's all transparent. They don't have to bother. It's easy. It's simple. It's cool. If you got remote users, big sales force in the field. Used to be you had dial-up through 800 numbers. Incredibly expensive. And not exactly secure, as I'm sure. Has anyone here ever war dialed? No? No? Oh, no, then this is all wrong. We should go back to dial-up. Okay. But yeah, instead they can just dial up locally into an ISP. The ISP takes care of the headaches of rebooting the modems when they lock up, doing all that stuff. They'll use a VPN client like Secure Remote. They'll tunnel through. They'll have access to the network resources, and they're good. And it's cheap. Also, take that one step farther, telecommuters with broadband. They can make almost as much use of the network resources as the remote office. Again, you're going to use some kind of a client, like Secure Remote, Secure Client. There's a bunch of them. I've been doing a lot of Checkpoint lately, so forgive me if I just lean hard on the Checkpoint stuff. It's just what pops to my mind at the moment. Okay. Challenges for a VPN. Speed. It's a network device. It's transparent. So it's got to be as fast as possible. But that's hard to do because it's got this overhead to crypt everything. You know, it's hard enough to keep your uptime going with all the hops, and you know the internet's getting a little crazy lately. So you know, speed's hard enough without having to process all the packets and change them, and then unchange them again at the other end. You got to worry about uptime. You know, your connection has to stay up. If a normal network connection breaks for just a few seconds, you know, it comes back up when it comes back up. The router reboots, or you know, whatever failover system picks up, everything goes back to normal just like that. No big deal. With a VPN, well, the connection goes down, your VPN goes down, your VPN might not come back up. Or for that matter, stuff that won't put a router down, like some straightforward little glitch in software, that'll put a VPN connection down. Some VPNs are very flaky. They tend to go down all the time, and that's a major problem. Sometimes you have to worry about the reestablishment. Session key is all over again, all this trouble. And then meanwhile, all these connections pile up. They're pending. They're trying to recover. They're trying to reestablish. And things get a little messy. Scalability. That's a big thing. It's hard to guess what your traffic's going to look like using a VPN if you've never used one before. It could be you think, it's going to be really simple. Oh, they're just going to check mail. It's like, well, you've never done this before. You've never put Microsoft Exchange over a VPN. You don't know what kind of traffic that's going to generate. You don't know exactly whether they're going to be checking their schedule. You don't know what it's going to be like when they download that 2 meg file across a VPN. You don't know whether this user over there is using local folders, and so as soon as he plugs in, it belches all the email to his laptop. It's a tough call. So it's hard to predict how big you're going to get and what traffic you're going to get. And it's always the case that they always plan for less users than they actually end up having, and that's another issue too. Interoperability can be a problem. I think people have pretty much given up expecting that this VPN should be able to talk to that VPN. It just isn't working out that way. Down the road, IPsec will probably take care of that, but everyone's just content to wait until that day comes. But you have interoperability problems within a single VPN system if you have to have mixed levels of crypto. If you're a multinational company and you're not a financial services company, you might not be able to export strong cryptography without using key escrow, which means that your field office in France is running 40-bit. Your field office in San Francisco is running triple DES 156. Your VPN's got to be able to talk to both of them. It's got to be flexible. Okay. Risks involved in VPNs. Nothing's perfect. You always have some kind of a trade-off. There's always some thorn on the rose. First of all, since VPNs work across public networks and they're supposed to, they must be publicly addressable. If you've got a gateway that's only supposed to talk to another gateway, and you know that this IP will always talk to that IP, and vice versa, and never any other one, okay, you can hide them in the firewall rules. That's no problem. But that's not all that common. Most of the time, what you're going to have is a VPN that is visible to everybody, including whatever script kiddie might be in the third row right now. Sorry to the third row, I just had to pick a number. You have to worry about where you put a VPN on your network. The trick is, you put it behind your firewall, okay, we'll put it on the DMZ because it accepts connections from the outside world. Okay, sensitive, unencrypted traffic goes into the DMZ from your back network, goes to the VPN, comes from the VPN, back out, goes out to the internet. Encrypted traffic comes in from the internet, goes to the VPN to the DMZ, comes out of the VPN, unencrypted, in the DMZ still, goes back to your back network. And then somebody hacks your web server and puts a sniffer on it. This is bad. Put it in front of the firewall. Oh, that's good. Hey, let's install it on NT too. Service Pack 3? That's a lot of trouble, man. I never bother with service packs. There you go. Okay, so you can't put it in front of your firewall, and you got some trouble if you put it on your DMZ. You definitely do not want to put it on your back network because that's just like a rule of thumb. Don't accept connections from the outside untrusted world into your back network. That's very, very risky. And the reason why is because you don't know what vulnerabilities might come up later. If the public cannot directly address a box, the public cannot directly attack it. They'll have to hopscotch to another point. And that buys you enough time that you might just notice them coming. Or not. You can put it on the firewall. You know, going back to checkpoint, that's an option. Thing is, though, the firewall's already pretty busy, and you put encryption on it, man, that's a lot of memory, that's a lot of processor overhead, and it goes back to what I was talking about before, about you just don't know exactly how heavily hit this thing's going to be until you start using it. So you might end up taking your network connection down or really, really, really downgrading your performance across the board for both VPN traffic and regular traffic. And that's a problem. That's going to get you fired. Okay, how to bake a VPN. And thinking about this, I was thinking more in like kind of a Betty Crocker concept, but I see it up there and I'm thinking it's like, well, no, I'm not at the part where you learn how to attack one yet. You got 3 things that a VPN must have. One of them is crypto, duh. One of them is authentication controls. The other one are rules defining what will and won't be sent over the connection, the encrypted connection, and in what way. Ingredient 1, the crypto. Okay, so this is your first challenge. You've got to encrypt communications, and everything else in the VPN revolves around this function. This is the core. This is the reason for being. What do you use for crypto? You got 2 categories, 2 general categories of crypto. You have public key, and you got symmetric. Well, you can't use public key for all your traffic because it just takes forever. That goes back to the speed issue. Very processor intensive. And if I remember correctly, some of them actually increase the amount of data you're sending. Is that? Oh. Yeah, by a lot, which is not what you want over your internet link. Okay, so you got to use symmetric. Well, okay, shared secret. How do you share the secret so that you can establish trusted communications? It's a catch-22. You can't trust your communications channels, so you set up a VPN, but you can't set up the VPN because you can't trust your communications channels. Well, Diffie Hellman is what gets us there. I'm just going to blow through Diffie Hellman real quick, just in case, just to cover it. Diffie Hellman in a nutshell. It's RFC 2631. We're going to talk about it in a kind of Dick and Jane concept that'll follow through for the rest of the presentation. You got Dick and Jane. They need to derive a shared secret. They don't want to pass anything across the network that a bad guy could see and use against them. So Dick and Jane create a key pair, a public and a private key each. Dick sends his public key to Jane. Jane sends her a public key to Dick. Dick encrypts Jane's public key with his private key, and vice versa for Jane. Both encryption actions result in the same thing. They now have a shared secret, but the nice thing is they've never had to send their private key, which is the thing that they have to protect, over the wire. So therefore, nobody knows what the private key is for either party, and nobody can derive the shared secret except Dick and Jane. Diffie Hellman requires random numbers for key pair generation so that nobody can guess, because there's basically 2 variables. There's a large prime number, of which there are a finite number, and then you've got a random number. And if you know those 2, you can recreate the same thing every single time. That's the potential weakness of a Diffie Hellman, is if there's bad random seed. As you'll notice, I say, remember this point. It will come up later. And if you really want to look at the math, okay, there it is. I kind of edited it slightly to make it a little clearer, and shoehorned it onto this. I tried to make it as short as possible. This is about as good as I got it. But you can see here you've got, Jane's public key, Dick's private key, mod P, is the same thing as Dick's public key encrypted with Jane's private key, mod P. And P is a large prime number. The public key equals, never mind, it's in the RFC. In math, I hate math. I think I was with my girlfriend when they covered that in college. I had to go back and learn it all over again. It was terrible. Okay, so back to the ingredients. Ingredient 1, crypto. Does your VPN protect Dick? Okay, so now you get the ability to do symmetric cryptography. You got the Diffie Hellman, it's going, cool. What symmetric algorithm you want to use? Most people are using triple DES. That's the buzzword that the marketing people are throwing around. That's what everyone wants to buy right now. You got other stuff like elliptical curve. That seems to be pretty good too. Heard some stuff on Real Secure, I hear, just a little bit before this. Might have been mentioned once or twice. That uses elliptical typically, although you can use whatever crypto provider you want. There's a few of them. Elliptical is the choice. Like I said before, strong crypto requires key escrow, or else they're not going to let you send it to the other worlds, because God knows what would happen if Hussein ever got his hands on a copy of the 128-bit version of Internet Explorer 5.5. Oh my God. I stay awake at night thinking about that. We will be assuming that the implementation we discuss here is using triple DES because, well, it is. We'll also assume that the triple DES is properly implemented because we have not been able to do code review to ensure that it is, but all indications are that it's pretty good. I should note here, however, that triple DES, like any other algorithm, is dependent upon certain variables, and it's possible to dumb the thing down if you don't do the right work. It's like any other crypto algorithm, you can weaken it if you do things wrong, and it's good to make sure on that tack. Okay, ingredient 2, authentication controls. Does your VPN know dick? How do you know that the person trying to get into your network should be granted access? How do you know that the person trying to talk to your BDC should be allowed to and get their email from Exchange or talk to the IMAP server? How do you know, when do you check who they are? Do you establish encryption with them and then authenticate clear over that encrypted connection? Maybe. If you authenticate before, well, okay. How do you keep someone from seeing the challenge and the authentication come back? If you encrypt after, well, how do you open? How can you possibly open a session without letting someone in? Okay, Authentication Solutions. You got options similar to CHAP, you got Kerberos, and you got some PKI stuff. This is just a short list of the options out there. Obviously, authentication is not something specific to VPNs, and so therefore it's a whole thing in of itself. A lot of people have worked on this, and there's been a lot of discussion. There's a lot of solutions out there. Some of them are great, some of them are disastrous. But, you know, so we're not going to go too deep into this because that's a whole other thing. We could have a whole other session just on authentication. But the key here is that it's really free form. There's a lot of things a vendor can do. It's not one of the things that people are going to look at very closely, likely. And so therefore, it's a good place to look for some weakness. Ingredient 3, Rulebase. Does your VPN allow dick? What does and does not get encrypted? Let's say you have the VPN sitting on your firewall. Obviously, it's not going to encrypt everything that passes through it. If it does, you're going to have a very, very hard time searching Google. So it's got to know what it should and should not send as clear and what it should not send as encrypted. This is going to be based upon many variables. 1, type of traffic. 2, where it's coming from. Or 3, where it's going to. There can be a lot of detail to this. There can be a lot of options. It's complicated, and just about every implementation is proprietary. What you want to do is, oh, that's right. In the event that you have interoperability with multiple strengths of crypto, the Rulebase might have the option of enforcing crypto to a specific provider, or it might not, in which case you might be able to force the crypto lower. You just say, oh, I'm sorry, I don't speak that fancy strong stuff. Send me the 40-bit. It might do that. Okay. We talked about all this stuff about VPNs. You know, what was the point of all that? Well, we've got an idea now of what some of the stumbling blocks are in implementation and design of VPNs. So now we know where the chinks in the armor might be. So we can start looking at them. You're talking about ingredient 1, the crypto. You can look at the key exchange because it's got to happen in the clear. There's no crypto yet. So you can attack that in some fashion. You got to look and see what's there and see what that gives you for an option. We'll do that in a minute. You can look for weak entropy. You know, I find it really, I find it much easier to like seed from the system clock because it's like, you know, really, it's just really easy, like XOR. in clear text authentication. Ingredient 2, authentication. Set up a VPN client and just try authenticating. Just try random stuff and sniff it, see what you get. Maybe you might get just like a little bit of a beginning session, and in there you might see an option to go a little deeper. Ingredient 3, Rulebase. See if you can force the encryption lower. See if it's interoperable. See if there's anything in the session authentication and session creation events where crypto is specified in terms of level, where there's some option for strength. Because if so, odds are you can make it go weaker. Oh yeah, one other thing. VPNs, as I said, are publicly addressable. Try overflowing them. Okay, case study. A VPN that doesn't protect Dick. Poor Dick. Imagine a theoretical software-based VPN. We're going to walk through a validation and verification of this system that did not require having any access to source code, and we didn't have any more information than was available on the website and the installation CD. It's kind of funny. We're going to show you some packet contents, including 2 packets, one of which causes a buffer overflow. Well, we're actually not going to show you the second packet because it's a little bit too easy. It creates a denial of service. Okay, you may have guessed it's really not a theoretical VPN. I can't tell you which one it is, though. There are vulnerable systems out there, and we're under NDA from the client. And just asking if we could disclose, just nicely. It's like, hey, how are those upgrades going? Mind if we disclose? It's been a while. And, next thing you know, it's like lawyers being dispatched. It's like, whoa, we were just asking. God. Unbelievable, man. So, and, it was a salesperson behind the Fuhrer. Can you believe it? I'm surprised. Okay, and, we can't tell you who makes the VPN system yet. We can't tell you who's using it. Can't tell you what it's called. Please don't ask. No, we're not feds. We're not going to play 20 questions either. Should be the first clue that we're really not feds. Oh, did I say that or think that out loud? Oh, sorry. Okay, first step. Read the insert word here manual. We looked at all the documentation that was available to the unmentioned, unnamed public. Stuff off the website. We looked at their website, saw what they had. Looked at stuff on the install disk. That was juicy. What was on the install disk was kind of neat. We found out. You want to tell them?
Sure. Uh-oh, got mic issues here. It was quite interesting. For the first 3 or 4 pages, actually, inside the installation manual that explained the authentication of how a client connected to a server, one could actually synonymously replace the word user with hacker. And I said we were playing some Unreal Tournament reading the PDFs, and so he's over here shooting things, and I was like, hey, listen to this. The hacker sends a ticket to the server and kept on going from there and said, this seems like almost a yellow brick road by which we can just get there. So it was almost exploited before it was exploited.
Yeah. Is it working? Sure. Oh. Yeah, the VPN microphone, ladies and gentlemen. Okay, it was a riot reading this stuff. It's like, like 1 in the morning, 2 in the morning, something like that. It's like we've been pretty much working all day, setting things up, trying to decide our attack pattern on this whole situation. And we're looking through the documentation, and sure enough, it's like, oh, hey, look at this. As said, this product has a mechanism for recreation of session keys after the fact. This way, you can allow decryption of captured sessions by law enforcement, and other governmental authorities. Now, the cool thing about this is that because of this particular bit of architecture, this product got an exemption. It does not need to use key escrow to be exportable with strong crypto. which tells you how secure it is. The NSA feels really good that they can break this. The irony of that whole thing is that, looking at it from a strictly business standpoint, and as Mudge has actually pretty clearly stated, a business can't just be about being secure. We can't be like, we're secure, that's what we do. Buy our stock, give us money. It's not going to work. They have to make money, and it actually makes sense because of the key escrow and the export requirements. It makes sense to do it this way from their standpoint. So you can't entirely blame the company. You can blame them a bit, though. Okay. I got it. First problem. All session keys are based upon one shared secret between the client and the gateway. It's on a per user basis. No, strike that. It's on a client basis. It's on a laptop. Compromise that, you can generate session keys at will. Okay, you'd have to rip some of the code out of one of the utilities, but it's not that hard to do. And again, like I said, it makes sense to do this from a business standpoint. Otherwise, you have trouble selling it. It's like, okay, we've got a product that we want to sell to big, big organizations. Okay, so you're a multinational. Well, this is a great VPN, but you can only sort of use it because you can only send so much of the data, so much of this product overseas. You'll have to use the weak stuff over there. Yeah, well, that's kind of a headache, but what are you going to do? Well, yeah, you could just use the 40-bit everywhere, but you're really not going to buy our product if we make you do that, are you? So therefore, they do this. Second step, we actually start playing with the software. Set up a small lab, set up a gateway, and some clients. It runs multiple operating systems for the client, including the Palm, which is kind of neat. Imagine it drains the battery in about a millisecond. We then started just, trying around, making network connections, sniffing it, see what we see. Take a look. We want to see if we can find out what is in the packets. We want to look at it and see if we can reverse engineer the structure and see what the data fields are, try to figure out what's in the data fields, determine the properties of those data fields, things like that. Are they delimited? Are they fixed size? What do they have in them? What does that stuff mean? What is a packet? Things we can attack. We can look for problems with the entropy, not good seeds. We can identify data that gives away information and has to be sent in the clear because it's needed to establish the session. And finally, we're going to figure out the format of the packet so we can try buffer overflows, make packets that are too large in some places. This is the way the session works. It's entirely TCP based. This VPN is very cool. It only uses one port. Doesn't use any UDP, doesn't use any ICMP. It's all connection based. The establishment protocol is based on HTTP. It uses weird kind of gets that are proprietary to the software. And it's actually kind of neat because they designed it so it'll go across a proxy without any trouble. They even put the Pragma no cache in there. I thought about it for a minute. I'm like, wow, that's just weird. I wonder what would happen if you took that. Oh, yeah. I guess if you took that out, you'd get the same session every time, at least until it timed out in the cache. And they were very careful to make sure this will work well when you have some kind of a cache or a proxy going on. Okay, here's the session establishment sequence. Time request from client to gateway for sync purposes. What time is it? We're doing crypto, these keys will expire. So I need to know what time it is over there, so I'll set the time over here so we'll be in sync. So that we'll expire our keys at the same time and keep going in case we're talking for that long. The gateway says, oh, here's what time it is. Mind you, there's no crypto yet. So if you want to do anything based on time sync, you now know what time it is. Then what we will refer to as packet X goes from the client to the gateway. Packet X is really the key to the rest of everything we found. Packet X is the critical packet. It contains the information that is used to generate the session key. In the documentation, they talk about a ticket. This ticket contains everything you need to recreate a session key except the master shared secret. The concept is that if law enforcement needed to decrypt a session, they would have sniffed the entire session, including this packet. They could then hand this information over to the company who runs the VPN, not the company that makes it, it's not that, but the company who's actually implemented it. And there's like, all these user controls and like stuff like that, but basically end up with this utility that enables you to give it that data. It'll pull out the ticket, say, oh, okay, here's a session key, and by the way, here's all the decrypted traffic that you gave me. Oh yes, that's right. Again, it's TCP. We could see straight up his username, the name and version of the software, which I've had to obfuscate here, unfortunately, plus 2 fields of data that were a mystery to us. Here I've got some dumps. Oh. Can you see that okay? Yeah. Okay, basically it's a rough observer packet capture. It's not the easiest thing in the world to read. Let me look at something that's a little cleaner here. Well, no, let's go straight to this. Well, I break it out. I just show you the data section, and I'll show you the fields. Okay, it's not just the data section. I got the header. I lied. Okay, up here, for those that you can see, I'm sorry, it's up in Notepad. I tried to cram this stuff into a PowerPoint slide. It was just a disaster. There's no way it would fit. Here you see the line here. Hold on a second. Oh, that's a good idea. Hey, I don't do my expense reports in Notepad. Give me just a second. Let me get this. Yeah. All right. Got to learn how to do that in Vi. Okay. Here we got the get. You can see the method being used. There's the pragma no cache. User agent, that's all X's. That's my doing. And it's running on Windows. Accept. Then here. Oh, too far. Here you've got the username. This is what it was set on at the client. We're not sure what this is, at least not at this point. Ditto for that. And that's the rest of the packet. Okay, so this is the anatomy of this thing. We've got, the HTTP GET that we were expecting to see, plus, some other stuff, plus those 2 fields. Okay, we did this a few times and we compared. Did them at different times so that we get stuff based on different time variables. Even tried different usernames a little bit. A couple things we noticed. 2 fields, they're not binary. They're all in, everything's in the lower 127. There's no really weird characters or anything like that. In fact, the namespace is all uppercase characters, all lowercase characters, the plus sign and the slash sign, and that's it. They're all the same in length if you take note of the fact that, let me go back to that. Ah, cool, save the setting. You'll notice these equals at the end. Often these are padded out a little bit with equals, never that many of them, and the equals are always at the end. So, anybody have a guess what that is? Very good. It's base 64. One of them is part of a public key. The other one is the random number used to generate the session key. All your base belong to us, gentlemen. That's right. The source of the entropy goes across the wire into clear, provided you know how to UU decode. And guess what? It goes from the client to the gateway. Which one of them is the big NT server and which one of them is the Win98 box? And we all know how good that random generator is on Win98, huh? But, you know, then again, what the hell? You can just sniff the number. What do you care? You know? Okay, now we know something about how this system works at the packet level. And again, I'm talking about session keyed creation. You know, we haven't even, you know, in truth, this user we've been testing with, we haven't even set him up on the server yet. We're just seeing what we can do. So hey, let's try some invalid data, some random garbage, and some buffer overflows in some places. Cool. Okay, well, let's see. See, we went problem 1, problem 2, problem 3. Guess what? No, really, guess. What do you think we found?
It was really secure.
Sir? Does Microsoft know you're here? This is fun. Okay, did somebody make a good guess? That's funny. Yes, yes, yes. A buffer overflow. Packet X passes from client gateway. Okay. So it's coming inbound. Contains the name of the user. Okay, which means, therefore, if you're just finding out who the user is as you receive the packet, then you have not authenticated. And therefore, you must accept anyone who sends you a packet X, provided you're expecting it from some kind of a client. And this is the kind of thing, this system is meant to support remote users. So therefore, it cannot refuse packet X and still work, that is. So you can use a properly malformed packet X to route the gateway. But guess what? We found something else. There's a different malformed packet that will also cause a DOS with one shot. That's not all. You have no chance to survive. Make your time. Okay, the DOS packet contains a bunch of Hex FS, all of which are not where they should be. I will tell you that it isn't something that is UU encoded, or rather that should be base 64, but in this packet it clearly is not. Remember, packet X is supposed to be some kind of an HTTP action, and therefore you shouldn't be able to put binary data in it without violating the standard, so I guess they weren't expecting any. Oops. Feed it this packet, and we noticed something really interesting. What you do is you'd give it this, and it would be just fine. It would just hum along. It'd be nice and cool, and everything's cool. And we're wondering, gee, did this test work? And then, we'd just, disconnect the session. We'd let it finish, and then, wow, hey, process utilization just went up to 100%. And it seems to be staying there. Let's go to lunch and see if it's still there when we get back. 3 hours later, guess what? You got to reboot to get it back. Let me hand the mic over to the guy who's the real specialist in this part of it. Oh, 1 second. I'm sorry. I totally forgot the most basic bit of etiquette. I've been a real bore. My name's Rob Schein. I also go by Schoten. And this is Drew Miller, goes by Ender.
Okay, can you repeat that question? If it doing what at the end? What I believe, how this actually works is because it was coded to accept a specific form with specific length fields. There's no bound checking whatsoever. That in the case of the invalid data that was received, the code was sitting there in some type of while loop waiting. It was waiting for the valid data to show up for the authentication. And when the disconnect happened, it didn't act on the code until that. This is actually a good example of bad coding, because the errors for your socket or your connection state, you should have some type of common handling so that any possible errors would be generally handled the same way. I don't think that they actually implemented the handling of a disconnect while they were receiving data inside of the while loop for the authentication, in which case somehow it ended up continuing this loop after it was disconnected, waiting for data. Does that answer your question?
Are there any other questions at this point? I mean, yeah, in the red.
Did you try like coding it so it would actually conform based with
I'm sorry. The question, as I understand it, is: did we try coding it so it would conform to HTTP? Actually, we had that on the table. We haven't gotten that far yet, because from the client standpoint, they didn't want us to find all the problems in this. They won't. Yeah, they weren't expecting to find any. They just wanted to know if something was wrong. And about this point, this was about day 3 of our testing, and we were like, we need to have a meeting. We need to tell you something.
Your client is the vendor?
No, the client was not the vendor. Yeah, ergo the double plethora of lawyers we had to worry about. Any other questions? Back there, and that looks like an Evil Inside shirt.
Does it actually take a reboot to kill the process, or does it run at a higher priority to get you
I believe your question was that, did you really have to reboot? Is that correct? Actually, there was a case where we found that if you killed a certain service that was related to the service that was taking all, that was related to the service that was utilizing all of the bandwidth or the CPU time, and then started it back up, sometimes it would work. However, to just make it start from scratch, you had to physically reboot the machine.
Any other questions? Okay, on we go. Okay, now the buffer overflow packet. We're going to show you this one. Let's see, I'm going to tell you a little bit about it first. Heck, I'm just going to flip back and forth. Oh, look at this. All your base are belong to us. Who put that there? Yeah, I was feeling slightly disrespectful for the vendor at this point. And so that's what I put in as the user. Okay, well, whole bunch of Z's, which are 90 in hex, followed by the ampersand, and of course that's a very, very long username. One of the things we tried was in the GUI where you set up users, we figured out how many characters you could possibly fit in the field before it wouldn't let you take any more, and the limit was 31. So we were like, okay. They're checking that on the front end. I wonder if they're checking on the back end. Apparently not. So yeah, I just threw a bunch of Z's in there, and boom. And just for fun, you see some other extra stuff down there, but the extra stuff isn't really what kills it. If you don't have that there, it doesn't do anything. In fact, you really don't even have to complete this packet. You can just get the Z's and the ampersand, and bye-bye. It's not expecting a username that's bigger than 31 bytes. This kills the VPN service itself in one packet. All you have to do is connect to it with TCP, fire off the payload. You don't even have to send the FIN, because at that point, there's nothing listening to you at the other end. It also overflows the service. And no, we're not going to give away the offsets, exploit code, or various nuclear weapons. So, I'd like to close with some questions, but first, I'd like to express some gratitude for some people who are instrumental in this work. I think we both would. Yeah, I want to do this before we do the question and answer session because I just want to make sure that everyone's listening at this point. I want to thank Bob Ritchell, who is overseeing us in this project. He gave us great support, and he also just stayed really hands-off and let us work, put a lot of trust in us, and was very happy with the results. And it's not a lot of managers out there who aren't technical people who can handle technical people, and this guy is one of those people. If you ever run into him, you ever have an opportunity to work for him, by all means take it. It's great to work for him. I'm sorry I'm not working for him now, but it just hasn't worked out from a business standpoint, meaning the businesses that employed us. I'd also like to thank my significant other and soulmate, Jody. She's been incredibly supportive and very helpful throughout this. And here she is in the front row. I actually suggested that she offer a DEF CON topic next year on how to be a good supporter to your geek spouse. Yeah, you want that? Let me tell you, she has a lot to teach on that topic.
I really want to thank the Ghetto Hacker group, mainly a lot of the ones from Seattle that just give me a lot of support and keep on doing this type of stuff in my spare time to make something happen. And thank DT for letting me speak last year, because if it hadn't been for that, Rob and I wouldn't have met. And yeah, I guess the rest is history. So.
And I'd like to thank Ender, big time, because he came in on the project from the outside, and he was critical. I mean, we could not have done this without him. I mean that, man.
Without you.
I know I'm doing a lot of the talking, but he did a lot of the work. Group hug. There's only two of us. Is that really a group? Yes.
Do you have this presentation on the website somewhere?
There will be one. I haven't had time to. I've been kind of busy at work and haven't had time to throw up a website and put something up on it.
Where will we look for it?
It will be available, I believe,
There will be a link to it from the DEF CON website. No. In the white.
What do you think of hardware VPNs?
Ooh, okay. What do I think of hardware VPNs?
I was going to say that if there's any problems, it's going to be hard to fix them upgrade-wise. I don't foresee that as a profitable venture that is going to be something secure in the future. As far as the speed bonuses, possibly that you would gain, obviously that would be beneficial. But from a supportive nature, if it's made by engineers, most likely someone's going to find an exploit, and that'd be pretty expensive to replace a bunch of hardware all around the world. So.
Yeah, you said if it was made by engineers. What if it was made by the marketing department?
Yeah, that would be okay.
Yeah, because they'll use XOR.
Yeah, that's mad fast. Yeah,
XOR is mad fast. Okay, in the plaid.
One question and a comment. The comment is the hardware, if it's done in an FPGA, you don't have to replace all the hardware. You can reprogram it to it, just like software.
That's true.
The comment was that if you do hardware using an I can never get that bloody acronym right. FPGA. Did I get it right?
Yes, you did.
Wow, I did it right in public. Thank God. That you don't have to replace the hardware. It's like, yeah, but that involves some difficulties sometimes. And a question. He has a question.
The question was about, did you actually test an exploit utilizing the random number generator to actually get into the VPN, or did you just do a DOS? Did you guys actually get into the VPN on
If you were to take a hacker manual and start at the first page and say, this is what I would start with first as far as the most simplistic forms of attacks, we didn't get to chapter 2. We said, like, week 2, damn, I really wanted a chance to look at the crypto. So, to answer your question, the things that we found raised the red flag. There was no need to go any further with the work.
I would add that basically that work was not sanctioned by the client, and they had an enormous amount of pull in this matter. And they pretty much burned their hours on other things, and so therefore the incredibly despotic, this would be that business situation with the manager I referred to earlier, we both got nailed. The overriding larger corporation didn't want us working any further on this. You, sir, in the tie-dye.
Presuming that you were evaluating a different VPN and you had actually gotten past Chapter 1 and you felt that you were fairly confident doing okay, what would be your next step?
The question was, let's say it's a different VPN and we get past Chapter 1 without any denial of services or buffer overflows or any bad things like that, and you get to Chapter 2, what would the next step be? I would say the next step would be, okay, you've pretty much covered your bases, as I understand you describing it. You've covered your bases for untrusted sources, untrusted users. Next thing I would do is see what happens inside the encryption, if at all possible. Try to reverse engineer some stuff and see if a trusted user making use of the product could cause you some harm. Because that is the next realm. You, sir, in the green, way back there. Actually, this VPN had the option for IPsec or non-IPsec. In this case, it did not implement IPsec because of issues with regards to NAT. Actually, Ender's done some looking at some VPNs, but do you want to talk about that some, or? No. Yeah, that's kind of inconclusive. We're poking around some stuff, but we want to save it until we get some real solid stuff. Try a different direction over here in the gray.
Is this the current release of this particular VPN class you had to follow with, and is the vendor doing something to fix this?
Okay, yes, I should say something about that. Thank you. The question was, does this refer to the current version, or has it been fixed? Is the vendor doing something about this? The answer is yes. The vendor immediately took some really dramatic steps to address the issue. No, well, they actually did some really hard work. They actually worked through Christmas weekend doing source code review for the first time, and Merry Christmas. and actually, we were given very straight away a new build dated December 24th. And we were given this on December 26th. Yes, but that's a long story too. They have been working towards getting people upgraded, and there are a lot of signs of that. There also has been some rearrangement of personnel. So, some heads rolled, and the new heads are actually people who have been, screaming all along. It's like, look, we have to be careful. We have to do better security. And, now they get to say, I told you so, and now they've got the reins. And yes, the vendor is doing something about this. It's just that this is in a lot of places, and they want to make sure they get everything out there.
He also has to do the current version.
Oh, I'm sorry. By the way, that new build eventually became a new version, and that new version is not vulnerable. Black with a hat way back there.
Recommendations, current products out there, what would you personally use for VPNs, which you recommend to incorporate, and then the things that are on the horizon that you're looking at that you can talk about.
Oh, wow. Okay, that's a biggie. As for recommendations as to solutions to implement, stuff that I see, what was the second part of that again? I'm sorry.
First part is, what would you use now? The second part is, what would you use in the future given what you know?
Okay. What would I use now? Yeah, personally, I really like Checkpoint. There's a couple of reasons for this. One, a lot of good people have really hammered away at it. And two, last year, as some of you may have seen at Black Hats, when some of those people found something, Checkpoint didn't nail them, Checkpoint didn't threaten them, Checkpoint did nothing bad to them at all. Checkpoint gave them help, said, here, we will help you find the problems. Provided, and this is all we ask, tell us, let us put it in a new patch, let us issue the patch, then you can disclose. And so when they did disclose it, Black Hats, all Checkpoint had to do was put a guy outside that session with handing out pieces of paper saying, oh, by the way, the new patch that just came out 2 weeks ago fixes all those problems you just saw. So it's cool. We've got it under control. Frankly, when I see a vendor that responds that way, I mean, that is all the way to the edge of the spectrum of a best case scenario. That tells me they're really serious about finding what might be wrong in their product. They accept the fact that, hey, there's going to be flaws. There's going to be mistakes. It doesn't matter. We got to know what it is. We got to figure it out. We got to fix it, and we got to move on. And I feel very good about using a product like that. Yes, sir, in the blue plaid. Yeah, I'm gonna have to take a pass on that one. That's probably more than one vendor if I really sit down and think about it. I'm not gonna play 20 questions, but you know, I really like Checkpoint. Black shirt in the row. Oh, yeah, absolutely. But the thing about what they found that with regards to the FWZ, the question was, with regards to the Checkpoint stuff last year, it had to do with proprietary protocols, some of it, that Checkpoint has, the FWZ protocol. And, you know, obviously, you don't want to use stuff like that. You want to use stuff that's been tested, that's really been out there. You don't want to use proprietary stuff. But the problem is the FWZ protocol, that vulnerability existed even if you were not relying upon FWZ. It would respond to it even if you had mandated, you know, using like IPsec. Oh yeah, I stay away from the proprietary stuff. I mean, I'm not aware of a proprietary standard out there that's considered as good as the stuff that's open, that's been really hammered. I mean, I agree. Yeah. In the black, I don't know what kind of shirt that is. I'm sorry, a login screen? Okay, no, there actually wasn't a login. I'm sorry, the question was if you were to get to a login screen. Sorry. Okay, I've got to skirt the edge of circumspection here. The login screen per se, you know, your standard remote user-based VPN is going to have a software client that. Oh, okay. Did the GUI limit you or not? Yeah, actually, we didn't even test that because, you know, the thought was typically if somebody's going to try to root a box, they're not going to try to type shell code. You know, because it's rough on the hands. In the back, black. I'm sorry, say again? There are discussions currently going on with the vendor. We're trying to put, you know, lean on them a little bit more. It really, as much as anything, it's up to the client. But it's complicated. I hate to say it. I really wish I could say more about it, but you know, these guys are so twitchy, and I'm just glad that they allowed this much. Any other questions? Oh, I'm sorry.
Personal experience, did you like Checkpoint so much? Did you work with the Nokia IPSO boxes?
Yes.
Had any of those catch on fire?
Whoa. Okay. Wow. The question was, you know, I like Checkpoint. Have I worked with the IPSO boxes? Yes, I have. I really like them. Have I had any of them catch on fire on me? Not without accidentally spilling something into them, no.
I accidentally actually took one out. I set my iPad up on our 802.11b network at the same IP address as the firewall by accident. I didn't realize that at the time. And apparently when they cycled
from what, if I understand that correctly, he blew up a Nokia firewall with an iPack. Wow. Yeah, what he said was that he accidentally set up an iPack with an IP address identical to that of the Nokia, and when they power cycled the Nokia, it caught on fire. I've never seen that, but again, I've never seen that situation either. So, oh, that's bad news. Okay. Do I have any experience with Nortel? Okay, let me try to think. Is this? Okay. Which company that they bought did that come from? Oh, from Bay Networks. I actually haven't looked at Bay Network. Well, I'm sorry, Nortel's stuff yet. Have you? No, neither of you. Personally, I had some bad experiences with Bay Networks at a job several jobs ago with regards to support, and so therefore I've always kind of like turned a blind eye towards their stuff. In the red.
I'm still picking up the random key thing that they send over their text wire. And you said you didn't go there. And you said also that the new version coming out didn't have the DOS problem. And now, then it might seem interesting to check if you can actually use the random thing.
Yes, this is true, and we've been thinking about that. In fact, there is the possibility of being contracted this time by the vendor, and this is kind of a twitchy situation, and I'm not even going to go into the issues of potential conflict of interest and ethics and whatnot, but they're interested in having us test the new version. However, I have talked to some of the developers, and we both have, and they're genuinely concerned about the security of their code. And there's a couple of really good people on that team, especially, who actually may be here tonight. I'm not sure. There comes a certain point where you don't have the time, you don't have the funding to set up a lab again and go through and test it for days on end. Especially since I'm in DC, he's in Seattle, so it's a little twitchy. So what you have to do is you have to actually talk to the people and look them in the eye and say, are you really fixing this? And I honestly believe that these people really do care. Yes, in the dark blue, I guess. I'm sorry, is the question
Cisco VPNs.
Worked with or attempted to break into? We have not attempted to break into any of them. I've worked with them. And at the end of the row.
Any experience with
I'm sorry. Any experience with what? Free Swan. No, that's GPL'd? No. I'm sorry.
Has everything you've said in this presentation been true?
Absolutely everything we've said has been true. Like I said, I'm not a Fed man. What? In the white? We actually worked with a variety of hardware. The Intel stuff, we pretty much used compacts. I think we had 1 HP, and we also had a Sunbox. Okay, anyone else? Oh, one more. Okay.
You mentioned having a palm for doing VPN.
Mm-hmm.
What was your impression of how secure it's possible?
I don't know. Didn't really get into that, and I don't really know too much about Palm architecture. Really, I don't see it as a huge issue because the thing is that I do know this, and this is not true of any particular product, but pretty much across the board, is when you do the crypto on a Palm, you've got to doing so much processing. I mean, Palms are fantastic, but now they're being pushed to do stuff they were never meant to do. And, triple DES encryption, oh my God. I mean, it's only got a 2-color LCD in the first place. I mean, good Lord. It's designed for phone numbers, people. I don't know why vendors are trying to slam all this stuff into them. Basically, in a nutshell, I don't think VPNs over a Palm are really going to be that viable with the current level of hardware that's out there. Yeah. Yes. This is true. This is true. But that's a theoretical. It's a good. It's. Oh, I'm sorry. The question was the new Palm series, the M500 and M505. They've got that expansion slot, and hey, couldn't you put hardware encryption on there? It's like the answer is yes, but you got to worry about battery life because anything that processes a lot also sucks up a lot of power, and that's the other thing that happens on the Palm is that battery runs dry like so fast you couldn't even imagine. I saw another hand before I thought. No? Okay. Well, thank you very much, everyone.